the CStro. So in this Python for astronomy tutorial, you are going to learn two things. So first objective is to read and open FITS file from a Spitzer telescope which is in a space, and this telescope is used to take data in infrared band, and it has like four different bands, IRAC 1 to IRAC 4. And second objective will be to plot and show the FITS image present in the FITS file. So let's do it one by one. Okay, so first of all, we'll import some libraries. So you can import some libraries. Import library. So you can import so we'll read this FITS file using Astropy. So you can import from astropy.io import FITS. So this is used to deal with FITS file. Now you want to read file. So read FITS file. So type here say file equal to, and give here keyword FITS dot open, and give here a file name dot FITS. So in my case I have already a FITS file present from a Spitzer telescope, and its name is IRAC1.FITS. It's the first filter in IR. So this will read the FITS file. Now type here, so get file information. So what the file contains. So type here file dot info, give function, and run it. So here you can see that the file name is IRAC1.FITS. Its name is primary, and type is primary HDU. It has 77 cards, and dimension is it's a 2022 2758. Okay, so this is a 2D image, and data type is float 32. Okay, this much we have done. Now extract the data. Okay, or you can do one thing, extract data. So extract data, or extract called image data. Extract image data. So you can type here image imj equal to, or just type here image equal to file. So here image is in your like primary HDU. So for primary the number is 0. So we'll put here 0 for primary, and type here data dot data. So this will extract your image data. Okay, you can put here say image, and let's see what it is printing. So image, so it is giving some not number values, but it will contain numbers in those between. So you can check it. Say I want to go from 1000 to 1500 pixel. So here's a value, negative value. So it means that the image contains 2D array. Now you got your data. Now you can also get header information. Okay, so for that type here file 0 dot header and run it. So here you will get a lot of information from this header. So you can see that it has axis, two axes are pixels in, so x is in like 2020 and y is in pixel size of 27/8. Okay, and this origin is a spatial telescope and bits file. You can see the time and experience information. So it's a IRAC spatial telescope, within the 3.6 micron, and you can see the Julian date. You can see the exposure time. Then you can see some information about. Then you can know about data processing information, and then you can know about photometry. The B unit of flux is megajansky per radian gain, and you have a 0 point in every system, and you have astrometry. So you have these are like transformation matrix to convert from WCS to image and image to WCS. We have array. Yeah, so those things is present in the header information. Now our job is to plot this. Okay, so you got information. Now we want to plot it. Okay, so so we have read the file. Okay, and you can print here data. So image. So this is the data. It is not visible because some values are like missing. Now our second objective is to plot this fits image. Okay, so for that you are import matplotlib library to plot. So import matplotlib.pyplot as plt, and then you can simply plot plt.image. So for 2D image, 2D data, and pass your data image. Okay, type plt.show. Now run it. Okay, so here you can see that this is the image and this is the pixel, x pixel and y pixel. Okay, you can see that you cannot see any image on that. Okay, so CCGs are like basically a linear scale, so you have to go on the log scale to visualize the intensity of the object. So for that, type here from matplotlib dot colors import log norm, and then pass here norm equal to log norm and give a function. Now run it. Okay, so now you can see here some objects are visible. They may be stars, galaxy and other objects. You can also do one thing. You can see that there's a mismatch at the origin because y-axis is reverse. So for doing that, you can type here origin equal to lower, and then you can see that now at your origin is coinciding with your 0. So earlier it was not coinciding. So this way you can do. Now you can see the object by zooming. So for that, zooming this the image, add here percentage matplotlib widget. So it will add interactive control. Run it. Maybe you need to put below the comment. Okay, so here you can see that you got some set of buttons. Now zoom it. Okay, so here you can see the features. This is a galaxy. This is R.05 galaxy. It's an interacting galaxy. There are other galaxies nearby it. You can go back here, and then you can shift. You can go through the whole fits image, and you can look for the object of your interest. Reset it. So this way you can visualize the object by zooming its portion. Okay. Go back to home. Now you can also add a color bar to show that how intensity varies across the plot. So for that, type here CMap, and you can see give jet, and you can plot color bar to it. So purity dot color bar. Okay. Yes, CMap. Okay. Okay, so here you got a color bar. You can see that how your image intensity is varying from pixel to pixel. Okay. You can also make it to gray. So image will look in a black and white color. You can map to rainbow. There is all sets of variant in that. So I like jet. So this way you can show fits image, and you can also give a title to it. PLT dot title picture Iraq 1, and then you can put X level and Y level, that what are the units of the image along the axis. So it's pixel, can X pixel, similarly for Y level. Now run it. So here is your here should be Y, not X. So Y pixel. Okay, so here's like very good view of this plot in terms of unit and title. Okay, so this way you can visualize your image in pixel coordinate. So I hope you got the idea, and if you like move the cursor along across the object, you will see here how the pixel value is varying. Okay, so I hope you got the idea that how to read and open fits file from a spatial telescope and how to plot it. So here's a code. We have read fits file, we have got information from fits file header, and we have extracted data, and then we have plotted and pixel scale. So thank you. Now you can also plot this image in WCS coordinate system. So WCS stands for World Coordinate Systems, I mean your array and deck. So let's do it in WCS. Okay, so for that import, so from Astropy dot WCS import WCS coordinate system. So it deals with WCS, and then you can define your, then you can extract your, so extract WCS coordinate from header. So for doing that, type here WCS equal to WCS and then give your file name. So file and then 0 for your primary HDU, and then you get your header. Now run it, check it what is the WCS. So this is like matrix which convert from a pixel to WCS coordinate system. Okay, now you can print it if you want, print WCS, and now you want to plot it. Okay, so plot this into WCS. Okay, so for that type here plt dot subplot and projection you can give it to a WCS, and then type here plt dot, I think that will be enough. And then you type here plt dot image show and pass your above, or maybe you can pass your whole line of code, and you can type here plt dot figure. Now run it. Okay, so here you can see that here is an image, and this is in your array, and this is your deck. Okay, so this is your WCS system, this is your array, this is your deck. Okay, so the same image we have plotted using WCS coordinate system. So I hope you got the idea that how to plot fits image into using WCS coordinate system. Okay, you can also plot grid if you want. Plt dot grid and then plt dot so you got your grids, and you can also plot grid here plt dot grid. So this is how it's look like, and then you can take all things